Anyway, I can go back also, right? Diba? Okay. My gosh. Okay, this one. Oh my gosh, it's very heavy. Oh, dissociated molecules of an electrolyte over the total molecules of an electrolyte. Something like that. Okay, when you speak about electrolyte, it undergoes an ionic bond. So automatically there will be a reaction between the negatively charged particle and the positively charged particle, something like that. Or else, it is not an electrolyte without a combination of those charges. Okay, something like that. So, in the process, there's a neutralization reaction. Okay? Of course, neutral because positive and negative are attracted with each other. So in physics, that is law of magnetism, right? Okay. Unlike poles will react, and like poles will not react. Okay. Law of magnetism, something like this, or law of polarity, as you can remember in physics. Okay. It's just like the theory like that. Okay. Okay. Going back. Okay, we have now the definition. Okay, and then we go now to the factors that affect the degree of dissociation, as I mentioned a while ago. We have the nature of solute, the nature of solvent, okay, the concentration, solution of the concentration, okay, and then after that, we have also another also factors that will impact to the chemical reaction of this dissociation discussion will be on the equilibrium constant, represented as small letter K. Could it be Ka, which is the equilibrium constant of an acid or acidic solution? Could it be Kb, equilibrium constant of the basic solution or a basic substance, something like that? Or could it be a Kc, equilibrium constant of the concentration refers to either the concentration of the reactant or the product, so it should be Kc, or it could be represented as a symbol Kp. It could be the equilibrium constant in terms of its partial pressure. Okay, so there are four keys like that. Okay, remember the Dalton's law, okay, of partial pressure will still be incorporated to this equilibrium dissociation of molecules. You remember that one? Okay, and the Rayau's law, okay, because it involves partial pressure of the solvent in a solution. Okay, a lot of pressures are discussed there. It would be also applied here. For example, because some problems are not specifying the molar concentration, it also specifies the pressures, the partial pressures. But then, the same theories and principles will be applied the relationship of partial pressures and the molar concentration. So much with the molar concentration, the molality, or the normal concentration of the normality, or like that, blah blah blah, so and so. So it is always molar concentration, but no problem. You can compute that one if we encounter normal solution. Okay, molar solution. Okay, molar meaning the unit of molality. Okay, normal, the unit of the normality in terms of terminology. Because if you try to break down that one, the unit of normality will be equal to the grams equivalent of the solute, okay, of a substance over the equivalent to weight, something like that. Okay? And then for the molality is equals to the moles of solute over the kilogram of solvent. It should be most of the times water, H2O. Okay? But others are sometimes not H2O. It depends on the solution that are being taken into consideration. Something like that. Okay? But normally, in the equilibrium dissociation of gases, we use molar concentrations represented in capital letter M. Okay? Blah, blah, blah. Okay? Take note for that because sometimes in a chemical reaction you will be given only the masses of the reactants and you have to compute the number of moles, blah blah blah, so on so on forth, and then you have to get the You'll be enjoying that also because there's a relationship between the molar mass like this, okay, grams per gram mole, blah blah blah, so on. So the unit of molecular weight, molar mass, atomic mass unit, something, and it's enjoyable if you love chemistry that much, okay, like that. Okay, so that would be the four factors that affecting the degree of the dissociation. Now here also, oh, what's the time now? Okay, I have still 10 minutes or 15 minutes to continue. Okay. Don't worry, I'll be able to have it. Okay. We have other variables, right? The temperature, the pressure, the volume, okay? And don't forget also the PVRT, the ideal gas law, the real gas law, the van der Waals equation, Boyle's law, charge law, blah, 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 so on. So we have to determine that one also. So don't forget that one, okay? So, okay, wait for a while. Say later. Okay, guys, I'll stop for a while. Me coming here. Oh my gosh. Ganun lang siya, okay? No, because I'm going to get my food now. I'm coming back. Don't you worry. I'll perform the lunch for you. Stay tuned, guys. Gosh. Hello guys! I'm coming back. Oh. Hello, I'm coming back. I'm coming back now. I obtained my food, my company provided food. Okay. So later, I will be eating my dinner. Okay, wait for a while. I'll just have to finish this live streaming. Okay. Regarding the dissociation of equilibrium dissociation of molecules. Okay. Okay. So here's the problem. The problem agad. Oh, okay. Wait. Okay. In the degree dissociation of gases, we need also to consider the dissociation factor. As we can recall, right? 1 plus alpha times V minus 1, wherein V is the total number of ions in a particular products, reactants, something like that. Okay, and alpha is still the degree of dissociation. Okay, because we don't know if the problem will also give the dissociation factor is like this, and then you cannot compute because you don't no longer you don't know anymore the terminology out of it. Okay, and sometimes it will be given into percent. For example, 80% ammonium hydroxide is dissociated like that. So automatically you can now compute the degree of dissociation for that. It will become 0.80, something like that. Okay, or because it's alpha. Okay. So alpha will be the number of molecules dissociated over the total molecules of the cross times 100. Okay, so 80 divided by 100.80 times 100, so 80%, something like that. So that's automatically 0.80. Okay, and then if it assumes to be perfect, so that's alpha will be 1. Okay, so that is for strong electrolyte. Okay, for strong electrolyte, our alpha, our degree of dissociation is equal to 1. So meaning to say the 100% dissociation, something like that, okay? Because percent dissociation is equal to the degree of dissociation times 100 man siya, something like that. And our degree of dissociation is basing on the chemical reaction man siya, usually the products over the reactants man siya. Okay, ganun pa rin siya. Okay? Like that. And if the alpha or the degree of dissociation is less than, so it's less than the equilibrium constant, like this. No, alpha or the degree of dissociation is less than 1, sorry. Okay, that would be the degree of dissociation for probably non-electrolytes, right? Oh, weak electrolytes, sorry. Because lesser man siya. Only strong electrolytes man siya. 1. Okay? So our formula for that degree of dissociation alpha will be equal to 100 minus x over 100 minus 100. So it's less than 100% dissociation siya. Okay? So lesser degree of dissociation. So meaning to say, weak electrolytes. Something like that, right? Not strong. Because strong electrolytes will be 1 man siya. So perfectly dissociated. That's why 100% dissociation, okay, or degree of dissociation like this is 1, okay, like this. So alpha, the highest is 1, okay, because that is the degree of dissociation, that is not percent of dissociation, okay, like this. So I think if it is more than 1, because I'm not really sure, it's no longer electrolyte, right? Something like that. Okay? What's the temperature ammonia partially decomposed into nitrogen gas, hydrogen gas. Ammonia was added to an empty container until the partial pressure of ammonia reached 0.85 atmosphere. O ganon. At equilibrium, the partial pressure of H2 was found to be 0.45 atmosphere. Okay? what is the partial pressure of ammonia at equilibrium. So at first look of the problem, sound very difficult, right? Imagine instead of molar concentration, you change it to partial pressure, something like that, because it's still applicable in the dissociation of equilibrium dissociation of molecules of gases. It's still considered a part of it. Okay, don't be afraid sometimes. It's only pressure, that will be complementary to the concentration. The others are not. Okay, it's only pressure and the molar concentration. Partial pressures and molar concentrations are directly proportional with each other. Parang ganon. Okay? Something like that. So, where's the enthalpy? Oh my gosh. But before that, I have to eat my cake. Oh my gosh. Cake. So here is the cake. So, in your own analysis, how much sugar is mixed? You cannot answer by just simply looking the bread into a sample or okay, with certain local regulations, could be the food industry, government, something like that. Okay, before it will be released in the market, there's a procedure or protocol for thousands of banana cakes for the employees. Okay, and then you can also compute mathematically, right, by doing that. Okay, but I already now with a substance containing sugar. Okay, my God, ganun. Actually, I weigh it, but I don't have choice. I have to eat this. Yes, of course, I'm waving it, right? Take a look at the coffee. There's no sugar. Okay, I don't drink juice with sugar. I only drink fresh juice coming from oranges, lemon, apple, or whatever. Blah blah blah. Chuba chu. Okay. And here are my again banana cake. Banana cake or cake. Oh my God. As my gifts to you, because Christmas are fast approaching, this will be equivalent to the sweet love I will be able to give to you. Right? Something like that. Generously given to you. I have to, I'm very excited. What's this? It's vegetable salads. Oh my gosh. Ta-da! Oh, I love this. This one sure I eat this vegetables. 100% I will eat this one. Oh my gosh. I do the segregation. Oh my gosh. Oh, diba? Ganon. Huh? There's a tomatoes inside. This one. Macaroni salad, pasta with too much cheese wrapped on it. Okay, with 2 additional slices of tomatoes. Oh my gosh, what's this other vegetables on the topping mix? Macaroni salad. Salty makes it fat also. So I have to control the amount of the intake of this food. Okay, like this. Because I don't like also the other version of Filipino food. This is usually the fish with too much bones. You know, fish with too much bones. I don't like bamboo because I have to scrutinize bone by bone. I cannot eat properly because it will obstruct my esophagus. Charot. Yes, it's very tasky to eat bangus. I have to examine bone by bone. Also eat it's sour, so very sour, and then I cannot manage to take that one next time, okay? In too much amount, something like that. Okay, hello guys, we're still there. So I will eat na, my gosh, tomato, oh my gosh. Tomato rich improvement of the health of the tissues and muscles in the eyes, like this, in the liver, in the lungs, in the kidney, something like that. Vitamin A. Okay. Okay. Don't ask me for the formula of vitamin A because I don't know. Oh my gosh. May ganun. Mm. Delicious. The tomato tastes good. There's a little bit sweetness in it. With a combination of sourness, something like this. It's good for the health. Okay. Okay, and then there are also this one. The green leafy vegetables are on the toppings, but I don't know what's the name of these vegetables. It could be lettuce, oh my gosh, or radish. I don't know. I forgot. Oh my gosh. Toppings of this. It's better to have more, right? Oh, the meat in the bottom part of this macaroni salad. Okay, in the bottom portion is potato galore. Oh, white rice because there's potato. Potato is carbohydrate. Okay, energy giving food. It gives you energy. Okay, same as bread, wheat bread, yogurt, same as cereals, beans, same as what do you call that one? The quaker. Most of the energy giving foods or carbohydrates are starchy foods. Okay. Don't ask me. Everything we eat, we should have a chemical formula for all the food we eat. So how can we describe the kind of world we are living if we are keeping on? Oh my gosh! Oh, very salty. Hello guys. Okay, not so. Not so, because last week they were they were preparing a very salty macaroni salad and pasta, but now it's okay. The taste is average. It's not too salty. It's not too tasteless like this. Okay. Oh my god. Hello guys. Kain na tayo. Diba? A cardileta galore. Wow. Because the color is too much orange, right? And then I remember when I was working in the, Tagbilaran Bohol, okay? And then we usually eat lunch there with a caldereta food menu. And it's very, very delicious. So, digested parts of the boat to the toilet usually is colored orange. It's just because we eat orange colored food. That's why it goes to the, your urine, something like that. But the problem is some of the orange color will stuck in the liver, in the pancreas, something like that, the small intestine. So that's not the problem. The accumulation of some of the food coloring there. Formula of food coloring, something like that. No need. Everything is trying to detect the chemical formula and we will be crazy. Okay? If we try to detect everything, the chemical formula of all the food we eat, and we will become crazy. Okay? Especially for the contents that we eat. Okay, we'll just estimate like this. Approximation. We can determine the level, right? If our stomach is full or not. Just like that, okay, then stop it. Just like a rubber band, there's an elasticity limit, okay? When the elasticity limit breaks or reached, then it will it will break up like that. So that's the same thing with our, it will break, so there will be bad effect, something like this, okay? This analogy, try to compare situations. Okay? See, I love eating too much. Oh my gosh! I forgot. Stop na. Yun na yun. Okay? I established stoppage. Okay? Ganon. So I will put this in the refrigerator. Okay? So in the corner, I have a very small refrigerator there. Okay, I have to put this one inside to preserve the taste of this inside tomorrow and calories. Like this. Oh. And then where's the and let's examine one by one what are the ingredients of this vegetable salads. Let's organize. Oh my gosh. Something like this. Okay. Okay. Lemon that kill bacteria, viruses, and bad microorganisms that will enter in our respiratory system. Cucumber wastes also health benefits of the right. Then we have the, what's the name of this one? Cabbage. Let's summarize this into one statement. If you eat green vegetables, okay, combined with fruits, this contain too much antioxidants. Okay, what are the purpose of antioxidants? These antioxidants will protect the cells of our organs from any pathogenic substances, okay, or any cancer-causing microorganisms. Very, very, very useful in our immune system. That's why we need to, okay, add more green leafy vegetables in our health system. Okay, so that's the purpose of antioxidants. Okay, like that. And the lemon, lemon is very alkaline. I think acidic. Sorry, acidic. What is the pH of this lemon? I forgot. It's gonna be 5.5. Oh gosh. Lemon is very acidic, right? It's very, that's why you can kill the bacteria, because most of the bacteria are not acidic. Especially when they enter the first time, if you drink too much water, okay? Especially early in the morning, if your stomach is not having food, okay? The first thing to do when you wake up in the morning, of course, you have to stretch your hands, your feet, your head, your backbone, something like that. You need everything in body parts because we need also to be exercised because we need to maintain the blood flow circulation. Okay, to remove the cloggings. Cloggings, the stacking up of those fats particles, okay, accumulated in the veins, the veins, okay, in the vessels, something like that. Okay, remove in the excretory system. And then after doing that sort of water, or a little bit hot of water, okay, to help to kill some of the bacteria inside our small intestine and large intestines. Okay, my gosh. And after that, drinking 1 minute for a little bit hot water, okay, you have to drink now the lemon water. Okay, to maintain the acidity of our internal digestive system, so that is something like this. Okay, and then after that. After the 3 steps, then you can eat now your breakfast. Okay? And your breakfast must be balanced also. There must be protein, there must be carbohydrates, there must be energy-giving food, there must be also a drink that contains energy substances, energy-giving substances also, so it makes you vibrant, agile, energetic. Okay? Good, especially if the TLV is very high. are taking that more than in our TLV, the threshold limit value. Okay, for the level must be appropriate, is within the range that our body can sustain or can endure. Endure can survive, something like this. Okay, so we should have 63 kilograms. Doing is very struggling my part, but I have to do it because I am struggling my part, but I have to do it because I am in the aging 40 plus, and then disease will be going out from your system. You have to be alert, and you have to be, disease will be going out from your system. You have to be alert, and you have to be right. But pressure also must be used. Okay, here equilibrium is the key term here. So we need to remember the method, the ICE method. Okay, ICE. What is ICE? I is initial. C is the change. E is you have to substitute in the equilibrium equation. Of course, the word itself could determine, right? Do not substitute the initial. Do not substitute the change. Substitute the equilibrium results of your calculation of your concentrations after that, determining the one. Okay? Okay. Hello, thanks for watching. Oh, you're enjoying my vlogging. Okay. You are also an instructor. No, I'm not an instructor, sorry. You are an instructor. Okay. My gosh. Hello, guys. Okay, by the way, are you sure that you want to stop streaming? No. Okay. Why should I? Okay. Okay. Why should I stop? Okay, personal confession. Before coming here, I was offered in Bahrain to teach chemistry, okay, something like that. And I didn't go to the final interview because I don't have courage. Maybe they will find my education, credentials, and everything, something like that. They got pushed, even though I have the courage and I have also the talent of how to be interviewed in the chemistry because I have also knowledge like it, but I never pushed through. It was okay. And then after that, there's also an opening for a certain university, senior high school chemistry department. Still, I did not go over it. I plan to apply, but I didn't go over it. The main reason is purely monetary, okay? Monetary or remuneration. Because the financial aspects are not yet too much compared to the career. That's only the main reason. Okay, but aside from that, speaking about tenure and stability, I love those, profession, okay? So that's why. Who knows after how many years, after 1 year, I will be going back to teach. Not going back, I will be going back there to teach. Okay. Like this. Okay? Like that. Okay, how can we solve this one? The first thing to do is analyze the terminology and write down the given. Given, okay, being asked are the partial pressure of ammonia. The ammonia here is our reactant, okay? Because the ammonia is being it's being put in the flask or the empty container. Okay, and that empty container has already the partial pressure that reach 0.85 atmosphere. So that could be automatically the ammonia inside that container. Okay, let's do the ice now. Oh my gosh. Ice good. Lagi oil. Hello guys. Mag-compute na ko ha. Saan hindi yung rasa? Charot. Some of the topics are unit operations, right? It started with screening, okay? Unit operation 1. And then screening, gas absorption, evaporation, humidification, something like that. I think topics in unit operations I've read. When I read the questions, I was shocked. It's very difficult, really. I could not just imagine, oh my gosh. Last 20 years ago, oh my gosh. Very difficult, really. I don't like screening also in the unit operations one. I don't want, because so many will pass in the screen, like this, the diameter, blah, 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 so and so. I don't like, I like evaporation. Okay. Evaporation, heat transfer. You know, if you study heat transfer, you can easily relate that in your normal life because there's always temperature around you. It could be a higher temperature, it could be a lower temperature, or the change in temperature in your everyday life is always been there. Especially in your aircon, you're inside the room, you will feel cold. Oh, the temperature is lower, something like this. Oh, it's very hot, the temperature is higher. So you can easily relate to the actual scenario. So it will create you an interest for that particular topic because you can easily relate and can really apply your interest for that particular topic. But if you talk about screening, what can I do with the screening? I guess it will go to the mesh, diameter, blah, blah, blah. Oh my gosh. And then also the gas absorption. Oh my gosh. Like this. It's okay also, but you know, it's not really that interesting compared to the evaporation, heat transfer, and the radiation, right? Because radiation, because we have the heat of the sun, okay? There's a radiation, radiant heat of the sun. You can relate also to that, okay? If more heat will be absorbed to your skin due to the, okay, due to the radiation, okay, your skin will becoming, you know, irritated. Epidermis, the outer layer of the skin. You know, you remember that in biology. It will hit to your epidermis. My gosh, the ultraviolet rays of the sun will react to your epidermis of your skin, and it can cause, you know, diseases in the future. So you need to protect your skin, something like that. Okay? It depends on the exposure, especially beyond 8 hours, 12 hours, 20 hours, like that. So you can easily relate in your day-to-day life. That's why I love the heat transfer topic, evaporation topic, and the radiation topic, something like this. And also, and it's easy to study water, right? Because there are only 2 atoms of hydrogen and 1 atom of oxygen anytime you want, right? Distillate and the condensate, oh, right? There are only two terms that you will be able to discover: the distillate and the condensate, plus the OMB, overall material balance. Okay, what's coming in, what's coming out, and the recovery, blah, blah. So you can easily relate to that. But comparing to the crystallization, screening, drying, no, I hate the topics also. Oh my gosh. And especially in the kinetics, you know, kinetics, chemical reaction engineering, like this, blah, 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 so on, so, and then in a very big reactor, like this, you could not just imagine, oh my gosh, what can we do this? Then you have to study the chemical reaction inside that. Very, very difficult, okay? So there's a lot of topics that you create the most interest, okay? For your strength, okay? And then you can develop scores for that also. Okay, it's timing also, because if the exam, for example, more and you love that too much, then you can gain too much scores for that, okay? It happens also that in the chemical engineering, what I love the most are also coming out, okay? There's a lot of heat transfer questions in that third day of the examination, and there's only few screening like this. So I was lucky enough. Because if there's a lot of questions regarding that I don't like also, maybe, you know, I will fail also, something like this. But it depends, because there are formulas also to that. All you have to do is study, right? But it's totally different when you study the topics. If you love it, place, there's a difference. Okay, if you study the topics, you are forced to study just to pass. It's not really that, you know, it's not really comfortable. But if you study the subject, it's in order for you to learn and you to apply that in your daily lives, very, you know, comfortable and very enjoyable. Okay? For example, chemistry or atmosphere composed of 79% nitrogen and with oxygen. I'm breathing that every day. Okay, without that, I'm dying. That's given by green, right? And the oxygen will vary to 20.9, 20.8% percentage by volume. Okay? volume of the solute over the volume of the solution times 100. Our solution will be the air. Our solute will be the nitrogen. So computing for the percentage by volume of nitrogen, computing the percentage by volume of oxygen. Our solute will be oxygen. Our solution will be the air. Something like that. So it's very enjoyable. We don't take oxygen, we will die also, right? So that's the power of if you study the subject that you applied in your everyday life. Okay? So it always starts with chemistry. Really. The world is made of chemistry. Okay? Everything. Like that. Okay? The soil, the chemistry of the soil, like this, blah, blah, blah. Where there's a calcium carbonate, like this, there's an oil shale, something like that, an iron ore, the rusting process, it eating up the surface of the metallic structure, that it will create leakages on the water pipe, something like that. Okay, that's through corrosion process, right? Due to iron oxide. A reaction of water to iron produces iron oxide. It could be an iron hydroxide. That way it turns brownish or yellowish because of the presence of iron, something like that. See, it's very enjoyable because you can relate and you can see in actual what's really happening. Okay, like this, I can see it's rusting. So chemistry is already there. Something like this is very enjoyable. Okay, so enjoyable at the same time learning, and there's an academic inputs out of that. Okay, but if you don't create interest for that, then you will not learn also. You will just leave that as rushed. Okay, and you don't know what's the process, why it became a rust, what's the formula for that, why it turned to rust, why it turns SCALE in different pipelines. Okay, be a utility pipeline, it could be a whatever, gaseous pipelines. There must always be the process of scaling. Here, the atmosphere will bring solid particles, they will contact to the pipelines, it will create a reaction to the water or the acid rain there. So it will corrode, something like that. There's a lot of corrosion, the pitting corrosion, the cavity corrosion. That is metallurgical chemistry also. See, it's very enjoyable, and you have to prevent that corrosion. And you have to apply solution for that. And use also chemistry to do that. In combination with the solution, you need to combine science, particularly chemistry, with mathematics, of course, for the computation of the design aspects, and then the new technology, application of the latest technology in order for you to solve that particular problem. Then at that time you troubleshoot, okay, the scales, okay, the rusting process, blah blah blah, so and so, okay. But before that, you have also to analyze the scales in the laboratory, right? You have to determine how many iron for this particular scales, and you have to analyze that in the third-party inspectors, like this, or in your own laboratory if you have in-house laboratory. You can conduct water analysis. You have to determine the TS, the total dissolved solids, the suspended solids, the iron, the magnesium, calcium, minerals. So because it causes scales also. Most of the salts are scales. Causes scales, ACELES. That's why most of the scales are white in appearance. Most of them. There's also grayish, brownish. Reddish are more on the rust side. Reddish and brownish, sometimes red orange, like this, blah blah blah, so on. So okay, like that, very enjoyable. You can do here also, especially if you're working in a gas plant and then there's a leakage. Of course, you have to conduct the gas testing, something like that. Blah, 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 so on. So you can also compute for the, oh my gosh, how many amount of H2 hydrogen gas escape in this pipeline. Oh, you can compute. And then you have, you can measure original volume there. Okay, so you can compute now the flow. Okay, the flow, the flow or the flow rate of the gaseous medium that passes through the pipelines, something like that. So ideal gas flow sometimes, but I think most of the times ideal gas flow. Combination of real and ideal, okay, because sometimes the flow will be turbulent, not laminar. Okay, in the fluid flow subject, the flow of the fluid and the gas are either turbulent or laminar. But in the laminar, it mostly, that's what I remember, mostly obeying the ideal gas law. Okay, the more it will become turbulent, the more it will become a real gas. Something like this, okay, by theory. So the way they behave inside the pipeline, something like that, the liquid and gaseous media. Not too much with the solid because solid is no issues of the diffusion rate. My gosh. Umang, oh my gosh, meron pa palang diffusion. Paano yun i-compute? My gosh. Hello guys! Are you the diffusion rate of the liquid and gas phase inside the pipeline, something like this, using the flow rate and the density of the liquid in mass and volume, and also in relation with the pressure, assuming that the temperature is remain constant, something like this. How can we formulate the formula for that? Oh my gosh. So just consider the ideal gas law, or it could be the real gas law. Okay, something like this. Okay? Gosh. Bakit lumayo ako? I'm a little bit far with the decision. Ano? It's still related, right? Related man siya. Okay, yes. Gosh. Saan yun? Mga parabola, di ba? We have to graph the result like this, parabola, hyperbola. So gas also will obey the certain pattern or shape of the gas behavior through graphical representation. It can be easy, laminar or zigzagging somewhere along the way. The behavior of the gases can be best described through graphical representation. Something like this. Okay? X and Y axis in mathematics, algebra. Algebra or trigonometry? I forgot. Gosh. Oh my gosh. Okay, simulan na tayo. Wow. Ang tagal. Okay. Ammonia. Ammonia is not the same, ha? Okay. Ammonia is LH3. Okay. Ammonia. Okay. Partially decomposed, meaning to say decomposition reaction. Ammonia will produce nitrogen gas and nitrogen gas. Well, it will produce nitrogen gas because by concept, nitrogen will not exist as an individual atom. There's no such word as nitrogen in the product. It should always be a gas. Okay, it should be into. It should always be into. There's no such. We can do only the N if we balance the chemical equation. We determine the atoms. Let's say nitrogen, put N. It's not N2 because our purpose only is to balance, right? Like that, automatically N2, diatomic gas. Nitrogen is a diatomic gas. Okay, permanent, not changing. There's no N0. There's no N without subscript. Okay, it's always. And in fact, there's no N4, there's no N3. Okay? Remember that one also in chemistry. Okay? Sometimes they'll confuse you like that. They'll give you one and then you have to rearrange and you have to correct which is the mistake before you solve what is being required. So, very, what do you call this one? Very catastrophic. The term talaga. Okay, very destructive to the student. Okay, because it's not being taught all the time in the classroom instruction that the be like that. But in the you will also give a wrong reaction in the exam. And then if you are not really using your mind something also, and you'll be confused, well, like this, and you will automatically balance even though there's entry like this, we have to like this, and it's not existing. That's non-existent. Okay, like this. It's always the N2. I discussed only the N2, what do you call this one? N2 evolution. Evolution plus hydrogen gas. You can do that for the balancing of the oxidation number, oxidation state. You need to calculate the total oxidation state. It's okay, you have to do the hydrogen without the 2 and the nitrogen without the 2. But in here, in the chemical reaction 2, do not confuse because that's another topic. Okay, like that, and that's only, what do you call this? Okay, now, NH3 is equals to N2 plus H2. You have to balance the second step. Okay, first step is to predict the product. No need to predict the reactant because the reactant is already okay, like this. Balance the chemical equation. Okay. If you obtain a fraction number of moles during your balancing, do not be afraid. Okay. Just involve algebraic expression by multiplying both sides to the denominator so that it will be cancelled and you have now a whole number. Okay. Like that. Because when I was in high school, I'm afraid to that. Okay. Lately, I just discovered in my college days that we should be afraid if you can obtain a fraction. I will normally stop like this, but it's not that supposedly. I learned from that. Okay, like this. Okay, nitrogen, like that. You can put nitrogen now because you're now in the balancing method. Not you should not do. You should not put into. You should put nitrogen. Nitrogen in the reactant, how much? Like this. So 1. Nitrogen in the product will be 2. Not balanced. Okay. If not balanced, what you will do? Okay, you will employ the law of conservation of mass, but it should be equal. So use algebraic expression. You let x as the number of coefficient beside the ammonia. Why in ammonia? Because ammonia has less atom of nitrogen, the one you assume in the less number of atoms. Because some students also, even me before, I'm confused also when I was in high school. Anywhere but the clue is you can only put the x where it is deficient in the number of atoms or less number of atoms. In here, there is less number of atoms in the reactant compared to the product. So I have to let x as the coefficient of the nitrogen besides the hydrogen x. Okay? Like this. Okay. So, equilibrium, law of conservation of mass. The atoms of nitrogen and ammonia will be equal to the atoms of nitrogen in the product. So, X is equal to directly. Okay. That's the principle behind why it become 2 during the balance. Not guessing what number you times. That's wrong. Actually, some instructors are teaching to students like this, assume it will be equal, and this will be it's not like that. There's a theory behind that. That's why it's coming like that. This is the correct one. Because of the equilibrium principle, that the atom of the equals to the atom of the product. When you equal that one, you can solve for the value of x. Not that assuming how many number, if 6 here, I will put 2 here, if 8 here, I will put. This confuses the students because they did not know the basic concept and theory for the law of conservation of mass. This is the weakness of some of the instructors in high school. They did not deliver this properly to students. Okay, even me, when I was in high school, I did not understand that's not the case. Later, I just discovered by myself in the library. Okay, because most of the time I spend my time in the library during my break. Okay, I will never go to the city and going with friends. Most of my time is spent in the library. Okay, like this. Study, read. My life is boring, but in the end, there's a fruit behind. You can reap the fruit of all your efforts. Something like this. Okay, so this is gonna be the exact one. Okay, not the 8 nitrogen here. Here is this. Why 4? What's the principle? Why 4? Because the numbers are balanced? No, it's not. Why? Why we need to balance that one? Because it should meet the equilibrium principle of law of conservation of mass. That the atoms of the reactant should atoms of the else it will not become balanced. Or it will become a law of conservation of mass, which is formulated in chemistry. Something like this. Okay? Not only the atoms, but all the amounts. Okay? Any amounts, but not the number of moles. Okay? Confuse that because if you add number of moles in the reactant, will not be equal to the number of moles of the product. It should be always general. Okay? So it will be a mole, except for the mole. Okay? And atom. Okay? Not so in the molar concentration also. It's not equal. Okay, for example, 4 molar of nitrogen added to 2 molar of hydrogen gas will produce nitrogen gas. Then you will add the molar concentration of the reactant. It will not be equal because it's not a theory, it's not a concept of basic chemistry that the molar concentration should always equal to the molar concentration to the right. Correct me if I'm wrong. Okay? Okay, like that. Okay, it should be the number of atoms or the mass because of the law of. Okay. We put two here beside the nitrogen ammonia. See? Two nitrogen here in the reactant and two nitrogen in the product. So it balance automatically hydrogen like this. Now, in the reactant we have 6 and some instructor will automatically put 3 also in the hydrogen gas to become 6. And the students will wonder why. Because we need to equal only. That's only the purpose, to make it equal. What is really the purpose why you make it equal? So you should obey again the law of conservation of mass. So I have 6 hydrogen in the reactant. Okay. So be confused. Because as the reaction become complicated, if you still apply this basic requirement, you will never get wrong. Unless your writing is very dirty, unless you confused too much. You have so many problems when you compute the problems like that, or you did not study very well, or during the examination you studied a lot, then it becomes during the actual examination due to panic, pressure, your like this, your negative thinking, but also your actual condition in the actual examination, not only the brain power and the preparation, it's also okay, doing leakages, like you need to follow them, and then the proctor say them, you catch them on the side, and then after the results, all of them are failed automatically because that is the punishment. Are cheating in the actual board examination regulation commission. So they will punish those who are copying and sharing leakages in the actual, in which the proctor witnessed and confiscated them. They still have to continue the exam, of course, but they have punishment for that. Okay, automatically either they will fail something like that. Okay, hydrogen is concentrated in the reactant, and then the product we have 2. Okay, so we go to the deficient. Let X be the deficient hydrogen, X. 6 is equal to 2x. Okay, like this. So X will be 3. Okay, like this. X will be 3, substitute 3 in the X. So it will become 3 moles of hydrogen gas. See, it's being shown why it's become 3, not just balancing the number. Okay, like this. So even now a lot of students are confusing with this, like this. Okay, I think they know that already also, but they're very tired also to do it systematically. Okay, because it's also in the what do you call it, the attitude also of the instructor, because they think that the students can understand easily why they will never expound anymore why it goes like that. But they fail. That is the most important thing that the student must understand. Okay, because after that, even though how complicated your chemical reactions, you can apply that method. They can still get the exact balancing of the atoms. Okay, because if you just assume that, they will be confused for other examples like it, and it will become complicated, especially too much compounds like this, and the principle are being lost. Okay, like this. Okay, unless the students are very intelligent. Okay, have very high IQ, more than the instructor, of course, but not all the students are having a high IQ. More of them are average level or even less. Okay, so you should adjust to the population majority of the brain capacity. Okay, not the with the intelligent. If that is the case, all of your students will fail. Okay, like this in your subject. Okay, that's why some students error TERROR just because of that, fact that you are very like like this. My gosh, especially old instructors that are very old in the university, teaching the same thing. Okay, in 20 years, 10 years, 15 years, they will never expound everything. The basic concept and basic theory, okay? And then the students will sleep like this, like that, like that. And very boring, really. Okay, in my first year college, very old, you know, instructor, and he's very intelligent according to them. He is top number 2 in the board examination, but he teach very fast, something like that. Okay, so we have now 3 input of here. Again, inspect properly. All your products will balance to the reactant. So I have now 2 moles of ammonia equal to 1 mole of nitrogen gas plus 3 moles of hydrogen gas. Okay, I inspect it visually. Hydrogen 6, hydrogen 6. Okay, nitrogen 6. Oh, sorry, 2, 2, 2. Balance. Oh, like that. Okay, balance na siya. Proceed to the next method, like this. Inspect visually. Now you know the ice method. Right, initial, okay. So in the problem, inspect one by one in the problem. If there's an initial, okay. A certain temperature of ammonia, pressure, ammonia, oh. Mayroon na siya, ammonia agad, pressure, ganon. Oh, 0.85. Okay, nitrogen product being mentioned like this, nothing. So you will have 0. If nothing, 0, like this. You discuss this in this manner. Nothing, 0. So that the students will understand. Do not just put 0 and then no explanation at all. The students will wonder why. Okay? Nitrogen, 0, because there's no pressure mentioned in the problem. That's the accurate discussion. Okay? 0. So if that is the case in this manner, all the students will understand. Okay? And a lot of passing percentage of the board examination or in any quiz, polls like that, because there's a competition also in the science quiz. I think most of the students will understand, really keep on fighting and who's the best, something like this, because they understand very well, even though the not so intelligent can understand also. If the instructor also will try to deliver his discussion very well in a systematic, okay, order, something like this, organized fashion, step-by-step method of delivering the discussion and explanation to the students, okay, something like that. I'm not talking to everybody, for some, because others also are very good in discussion. There's a lot out there also very good in discussion. Okay, we cannot just name, but there are a lot are very good also who try to discuss very well also. Okay, but I'm talking also for some who are very intelligent instructors that always assumes that the students can understand immediately what he or she is talking during his discussion, something like this. Okay, it depends on the instructor's attitude and personality, something like this. Okay, let's go to C. C means change, reaction. Okay, because most of the change is not mentioned on, because that is the time you will detect the initial number of molar concentrations like this, the mass. Could it be the number of atoms or anything that you'll be able to discover during the chemical reaction? Not focus now on the problem. That's a technique for the second method, C, change. Okay. So 2 moles of ammonia, so I have 2, right? So I have 0.85 initially. So I have 2. So during the change, for example, I am the ammonia. I will give my concentration to my products. Then to the products. For example, I have 10 pesos, let's say I have 100 pesos, okay? I will give it to my daughters and son. So if I will give 50-50 to those to my son and daughter, my negative, I don't have remained anymore in my pocket. So this is also the principle here in ammonia. So he gave the 2, so 2 minus X. Try to share to nitrogen gas and the hydrogen gas, or the same as the father sharing to his son and daughter the money he gave to his son and daughter, something like that. Okay, so this is 2 minus gas. Okay, will receive the molar concentration only given to them, so it is expected that it is positive. Okay, because they can receive positive X. Okay, like this, because X is a representation from their father. So plus X. Okay, both of them, because they are equal in nature. Why equal in nature? Because both of them are diatomic gases. At the same time, they don't have number moles in their, beside with them. Charot! My gosh. Okay, like this. Okay. Now, we will now go to the equilibrium, which is the ICE, ICE, equilibrium. Oh. That's the time we go there. The atoms of the reactant will be equal to the atoms of the product. Apply that there. Okay. So it will now become 8.5. Okay, like this. Minus 2. Okay. Because originally he has 8.85. Minus 2x. Okay, very clear, huh? Equals to 0. Because equilibrium. Kaya nga equilibrium eh. Diba? But since all are equal to 0, you need to put the 0 because it's in equilibrium. It's understood to be balanced. Okay, so 0.85 minus 2x. Okay, then here will be 0 plus x is equal to 0, or of course that is x alone. Okay, you should plus the 0 because it's initial. Since 0 is nothing, it's the same as x. Okay, like this. Because sometimes in the problem, it should be given initial also to molar, somewhere along the way. In this problem only, because this has no initial. Okay, what if in the next problem there's also given like that? And this might change also. Okay, like this, blah blah blah. Okay, now equilibrium of the gas, PQ, right? Like this. Like this. And we examined now, go back to the problem, is there something missing? That's the procedure, ha? If there, you have to review the problem, something missing. Okay, you review like this. Okay. At equilibrium, pressure of H2 found to be 0.45. So mayroon siya, there is a pressure at equilibrium. So you should put here on the 0.45 atmosphere to the H2. So X for the H2 will be automatically 0.45 because it was mentioned in equilibrium. Okay? So the X of H2 is 0.45 atmosphere in equilibrium. So the X will be automatically equal to 0.45. Okay. Now, since nitrogen has also X, automatically the visualization, he has 0.45 atmosphere. Okay, remember that one. Okay, like that. And then, what is the pressure ammonia at equilibrium? There's a word equilibrium. Okay, it's not saying what is the pressure ammonia initially. What is the pressure of ammonia during its changing? Oh, like this. It's say equilibrium. In the ICE method, it's focused on the E, capital E. So you have to get this 0.85 minus 2x. Okay, 0.85 minus 2x, since you have x already with 0.45 and you have subtract that 1, okay, and you will get how much? Like this. See, it looks like very difficult, very easy to answer, okay? Like this. Okay? Oh, okay, based on the review, guys, we still have review because see, let's see, it's not balanced, okay? So why hydrogen have 3 moles and then you didn't have the 3 moles? So supposedly this is 3x. Okay, see? This is the power of discussion not prepared or not scripted, because you can still go back to your mistake like this. It's not perfect discussion of the how it is being arrived, right? Unless you were going to vlog and YouTube, and then you can visualize that those uploader is perfect all the time because that is scripted most of the time. They prepare all their material and being ready. And then me, I don't have that idea. Okay, me, even though I will get mistakes, I will get correct. It's still part of my vlogging. Okay, like this. So at least in this manner, we can prove that somewhere along the way, we got mistakes, and if we review it, we can correct it. Okay, that's the essence of this kind of live streaming. Rather than you prepared it before you vlog, before you upload, or something like this. So the viewer, but in me, in my time, it's not perfect. wrong, but I always say, correct me if I'm wrong, so that I can issue error statement somewhere in my description in my video. So meaning to say, this is really live on the spot, not prepared, not scripted, something like this. Okay, so 3x is equals to 0.45, so 0.45 divided by, so I can really check during my review now, okay? Because if you prepare, you will just go directly and, perfect all the time. And this is such perfection, right? Okay, and it's 0.15, so hello guys. So the H2 have 3 moles shaft, so 3x shaft in the equilibrium. So 3x is equals to 0.45, which is the partial pressure of the hydrogen gas in the equilibrium, then x is equals to 0.15, substitute to the equilibrium. Very fast. So 85 minus 2 times 0.45, it will become 0.15 will become now. Oh my gosh. Okay. 0.3. I told you it is 0.3. Okay. So 0.85 minus 0. So 0.55 is our partial pressure of ammonia. Okay. So this question, what is the partial pressure of ammonia? The partial pressure of ammonia. Okay, the reactant we have, and then N2. Okay, N2 is right, and H2 is 3x, so 0.45, okay, plus x. Okay, so algebraically, so x is equals to 0.55, 0.5 minus 0.10 is equals to 0.45. Okay, like this. 0.55, sorry, 0.55, 0.10. So the partial pressure of ammonia. Yes. So if you add the 0.10 atmosphere of nitrogen gas plus 0.45 atmosphere of hydrogen gas, it will yield 0.50. In this, we can automatically say that the law of conservation of mass, the partial pressure also will be equal. A few just because of this, okay? So added to your concepts and theories also, newly added to your information. That will be equal to the partial pressure of the product. Just now, I discovered when I add I established and managed another theory out of the computation in which I did not learn before, just now. Okay, this is the power of, the power of learning. There are things that you can really discover for a moment, even though you didn't read that in your previous education. This is one of the example, really. I know that there is a Dalton's law of partial pressure, but the topic is not the Dalton partial pressure, right? That's why. Oh my gosh. But in Dalton's law of partial pressure, component A, component B, component C, component like this, okay? And this is in the equilibrium. This is different. I think there's 3 method I's, right? Initial, change, and equilibrium. Then I think in the Dalton's partial pressure, law of partial pressure, it would be in the no such step 1, step 2, step 3. It's only general. That the total pressure of the reactant will be equal to the total pressure of the product, or partial pressures of the product. Not necessarily only the I's method. Because I's method is applicable only in, dissociation of, molecules, something like this, okay? Finished. We did it already, okay? Things like that involving partial pressure, very easy na, okay? Don't forget that in your examination, it will come out like this. Okay? Guys, come. Hello, cockroach. Yummy. I see a compound N2O4. What is that? Dinitrogen tetroxide. How can we name that one? N2O4. And then N2O4, it's a gas, okay? It's still a gas, but the problem is, how can I name that one? There are two subscripts in the nitrogen and four subscripts in the oxygen. So it could be dinitrogen tetroxide. I'm not really sure, okay? And then it will produce N2 again, okay? Plus oxygen, and you will balance that one, something like that. Dinitrogen oxide is in 2O man siya. Okay? Dinitrogen oxide, which is the laughing gas. Right? That usually laugh all the time. That is N2O. It will also come out in the examination. Blanc is a laughing gas. Simple. Because there's no other laughing gas, only N2O. Dinitrogen oxide. It will come out in the, quest bowls, science quiz, something like that. But honestly, the corrosion process involves redox equation before you can come out to the product. So you have, I think, four equations. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 4 equations, but 8, pairs, something like this, before you can reach the rust, R-U-S-T. Then it will start with iron 3, because there are two valence, same as charge, okay, but the word valence is applicable if there are changing state, oxidation state. For example, zinc, the oxidation state of zinc, it will either be +3, +5. So if that is changing, that is valence, something like this. But the charge is always specific, +1, -1. So that's charge only. Okay? For example, oxygen or oxide, hydroxide -2. There's no hydroxide -3. So you can call only that as a charge or an ion. You can call that as a valence. Okay, because it's not changing. But the valence have the different, something like zinc. There's 2, +2. There are variable of the charges. That's why it's called valence. Okay, that's the difference in the terminology. Okay, but you can still use the interchangeably. It's up to you. But I'm talking only to you the real, what it's being called valence. Okay, like that. So the valence of iron, like that. So the valence of iron is 3. So if A3, then plus water, of course, because there's a water before it will become rust. Plus oxygen, of course, it will added oxygen normally in the atmosphere, and then it will produce like this, blah blah blah. Okay. For example, there's a condition, and this discussed in the class, in the high school, in the college. I just discovered this by my own. Okay, we know that there is percentage of nitrogen, percentage of oxygen in the atmosphere, right? And it is open. Okay, if you do the combustion process, for example, with butane, let's say, for example, why you did not add the nitrogen? Because it's also in the atmosphere. Theory behind that. Okay, supposedly you will do butane plus oxygen plus nitrogen, because you said, sir, it's in the atmosphere, it is in the environment, it's given by God freely. But why N2 is not added in the reaction? What is the property of that nitrogen? That it is not reacting to those elements. Okay? Because that is inert. That is non-reactive. Inert element. We speak of inert, that is unreactive to others, because by themselves alone, they are already stable in nature. So that's the reason behind. Okay? That there's no nitrogen. Just like a fire, right? Only the oxygen, the fuel will be there, and the ignition source. There's no nitrogen added. Then why? There's nitrogen in the atmosphere, which is in fact 59%, more than oxygen, which is 21%. So technically and mathematically it should have. Okay, but due to the theory, okay, basic concept in chemistry, it will not react because nitrogen is inert. Nitrogen gas is an inert gas, non-reactive, stable in its form. Okay? It can only be splitted through the products, but it can never be used in the reactant. Like ammonia, during our discussion of our problems, it produces N2 and hydrogen gas. Then N2 is present, okay? But it's never been a reactant. It's always been a product, but it's never been a reactant for the reason that it will not react. Inert. There are a lot of inert in the last portion. In the noble gases, you know that one? Krypton. That is noble gases or inert gases family. Krypton, xenon, argon, neon. Okay? Those are stable, gases that will never react. So that is inert. Okay? That's why they use that as a, cleaning of the vessel, because it's not reactive to oxygen. Okay? In the confined space, you wonder why you use argon, because that is non-reactive. Okay? And that's why nitrogen gas is not flammable. That's the reason. Because it is non-reactive. Even though there's a, ignition source, because non-reactive, it not catch fire by itself, right? By its terminology itself, non-reactive, meaning it will not catch fire. Inert. Okay? But it can cause suffocation. It will suffocate you, the content of nitrogen, and then it will suffocate you, and then you will be losing the oxygen in your breathing. So you will now develop asphyxiation, ESPHYXIAT, the loss of oxygen during breathing. So if you lose the oxygen during breathing, so especially the lungs needs oxygen, that's the time it will not function and eventually you will die. Something like that. Okay? That's the power of. That's why we need to keep properly all the nitrogen gases, because not the flammable hazards. Yes, it's not flammable, but suffocation hazards when it explodes. Okay? Or it will fall down, the contents will be released, something like that. Or if there is leaking that particular gas cylinder. So that's the hazard of nitrogen gas cylinder. Okay. All must be treated equally, whether it is flammable, non-flammable, because of the other hazards contributed to that particular gas cylinder. For example, this gas cylinder has an explosion rate, but it is not flammable. Yeah. Even though it will not. See? So check the individual hazards of those gas cylinders. Do not equate immediately that this is not flammable, it will not do another hazard. It will do another hazards, okay? And there's also gas cylinders, both have explosion hazards, have flammable hazards like this, and have also suffocation hazards, especially acetylene gas, okay? C2H2, acetylene, C2H2, yes, C2H2. Two atoms and two atoms of hydrogen. So I think that it double banded the electrons of carbon, because carbon has six, has six electrons in the outermost shell. Charot. And then this, the outermost shell, will be shared to the hydrogen. So there will be a band called polar covalent band, meaning unequal sharing of electrons. Still, the carbon has number of electrons are not shared yet, and he gave to the hydrogen. So double bond, two underlines. If you count that remaining atoms, it will become two. Okay, so that's why C2H2. It's not being counted anymore because of the two double bonds in between them. So that's why acetate chemical formula is C2H2 under the ENE family, derived from the chemical formula CnH2n minus 2. Like that. Okay? Correct or not? Minus 2, really, yes. Because ANE is CnH2n man siya. Okay? CnH2n plus 2. Sorry. So, ang double bond, CnH2n minus 2. Ang triple bond, CnH2n na lang siya. Yeah. Sir, N is the number of. Okay? For example, if you have butane, so butane is 4, right? So, substitute the 4 in the carbon like this. N is equals to 4. We substitute to the formula which is CnH2n plus 2. Like, and you can determine the atoms of hydrogen. The 4 will be automatic the atoms of carbon. Don't worry about that. Your problem now is only the atoms of hydrogen. For example, propane. So propane, the atoms is how many? Carbon of 3 atoms of carbon like this. Substitute that to the chemical formula. It will have C3H8 for propane. So under single bond or ANE family in organic chemistry. Law of hydrocarbon, something like that. So all combustion process obey that principle in organic chemistry. There's no excuse. Even though the benzene, the toluene, okay, what do you call the other one? The dichloromethane, the chloroform, the acetone, okay, the formaldehyde, okay, obeys the principle of hydrocarbon, okay, in combustion process. Okay, formaldehyde used for preserving the smell. Okay, some foods have formaldehyde also in order to remove the bad smell like this. Okay, and even the acetone, or right, like that. Now my question is alcohol will undergo combustion? Think. Alcohol family. What? The RCOOH? Yun ba yun? Kasi R represents the alkyl family. The alkyl family attached to the carbon. That's why RCOOH. For example, if you have propyl alcohol, so the alkyl family for the propane is the propane. You will attach the propane there. That's the OH, COOH, like this. So it's propyl alcohol, ethyl alcohol, like that. So if you make it simpler, ethanol, like this. Add only OL. If you don't want to mention that as ethyl alcohol, then use ethanol. It's just the same. Okay, if you don't want propyl alcohol, use propanol. It's just the same. Add OL and the last word. Okay, like this. And this is also called iso. Why iso? Because there's the same formula somewhere in the structure. So it is called in organic chemistry as iso. Okay, if it is equal in nature, something like this, then they put somewhere along in the, say, carbon number 1, carbon number 2, and carbon number 1, carbon number 3 have the same structure. It's called iso. Since it is propane, isopropyl alcohol. Ganon. Okay? And there's another thing na para meaning opposite. In the carbon, there's an upside, there's downside, also attached alkyl family, and then you can call this a Paracetamol. My gosh. I think para, okay? I'm not really sure, but me sure for iso. Okay? Of course, the process is isomerization. Okay? Because usually in organic chemistry, the process will be polymerization and isomerization. Okay? Like that. That's why. How many isomers? Monomer, like this, polymer. That's why we have the word polymer. It comes from isomerization process. Okay? Monomer, ganon-ganon. Diba? What's difficult in organic chemistry are the structural orientation of the compound. Very difficult to memorize. Okay, there's a pentagon, there's a parallelogram, like for example benzene, like it's 6 shapes, like a hexagon, something like that, and then you put the carbon there somewhere on the, the portion and go like this. Okay, that's the difficult in organic chemistry. Sometimes you'll be confused. Where can I can put this alkyl? There's a role. Okay, we know that, but sometimes other topics. If you attach another compound to the benzene ring, okay, ring. That's what we call as a ring. Okay, benzene ring like this, and then like this. Aromatic. Ano na aromatic? Aromatic hydrocarbons. Ganon. Diba? Hello guys, thanks for watching. I'm tired of writing also. I promise I can do that on, Thursday night, Friday, and Saturday. Okay, I can manage to do that, writing the piece of paper, the problems like this. Especially in the equilibrium, topics, very enjoyable because a lot of key, right? As I discussed a while ago. Key A, KB, KC, KG, KP, blah, blah, blah. Okay, like that. And sometimes, somewhere along the way, if the problem gives you the value of 100, equilibrium concentration expression. Equilibrium concentration expression, oh my gosh, Kc is equal to the concentration expression of the products over the concentration expression of the reactant. It's gonna be like that. In the equilibrium stage na siya of the ice method. Not on the INC, ice equilibrium. Okay? Like that. So sometimes the equilibrium constant is given. Equilibrium concentration, okay, you can obtain a quadratic equation in terms of x, which is the molar concentration. So in that manner, use the quadratic equation in algebra, which is negative b plus and minus square of b squared minus 4ac over 2a, wherein a, b, and c are constants in the particular polynomial. You can obtain a polynomial equation out of that problem because x are the molar concentrations. You let x right like that. And then the problem is you have a lot of square roots will be there. Square root? Because you have to cancel the exponential, the exponent of those, denominator, and you have to, square it, blah, 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 it cancels out, and then what will remain? The x is the concentration. But my point is, if you have a decimal point, not 2 times 10 to the negative 6, like this. Very difficult to get the square root for that without the scientific calculator. Okay, scientific and you will move that big 6 to the left because it's negative, right? 1, 2, 3. In the scientific notation rule in algebra, right? Move square root that one. It's very difficult, really. you're very headache. That's why I stopped that certain, problem because don't have scientific calculator. And then times 10 to the negative 6, blah, 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 so on. So it's not even perfect, the number. Let's say 1.4 times 10 to the blah, blah, blah. Okay, square root is you multiply the number itself, right? When you divide 1.4 by 2, it's 1.2. 1.2 times 1.2 is not 1.4 also. It's only good if there's a perfect, for example, 9. 9 times 10 to the, say for example, ano siya, 36, exponent 36. 9 times 10 to the exponent 36. Of course, your square root will be 3 times 10 to the 6. It's not like that always perfect squares. When you, multiply with a square root or 1/2, it will not be cancels out. I mean, you use the calculator, very difficult. How can I use that one? My calculator is not a scientific calculator, a grocery store calculator. That one. Okay? That's why I stopped that topic for a while, especially if it involves quadratic equation. Okay? The factoring, okay? In algebra, you can use the other one, right? The factoring and the factoring method and the quadratic equation. But in the factoring, it will not be applicable in the chemistry because there's two value of x. Okay? And remember, in dissociation of molecules of acidic solution, dissociated gases, we need to consider the sign, the negative or positive, because if it is negative, it is being reduced. If it is positive, it is being positive. Okay? Now, if you use that problem, it will not, the theory will not hold true because there's a negative sign after you factoring, right? You will equate that to 0 and you will get the 2x there in the factoring method. So you are forced to use the quadratic equation in determining the molar or either the molar concentration of the reactant. You force yourself to use the quadratic equation, especially if the equilibrium constant is given in that particular equilibrium concentration expression. Okay? Very clear, ha? Okay? Ganun siya. We are not yet accounting the Lechatelier principle, that if we add this, where does our reactant or the rest, only the mathematical amounts, how many, like this. But there are also another topics left. You go to the right. If you add pressure to the reactant, even up to now, you'll be confused for that also. If you add pressure to the reactant products, you add concentration of the product also, your reaction with the factors affecting the degree of dissociation, the nature of the solute, the nature of the solvent. Therefore, there's others, the viscosity, okay, the boiling point, the melting point, the freezing point, physical characteristics and properties of gases or compounds. So all of them have values that are tabulated there somewhere in the handbook, chemical engineer handbook, and then there's a table, a graph there, and you can get there at a certain temperature or pressure, you can get the value, okay, for this, like this, blah, blah, blah. And sometimes it will confuse you also because sometimes they put that also in a problem like that scenario, okay? For example, if you are used to the problem that does not, okay? In my problem, I don't give the temperature, but sometimes calculate the partial pressure of the ammonia at 20 degrees Celsius, something like that, also like that. Okay, that is not applicable already to that because that is not at 20 degrees Celsius. That is assuming that the temperature is constant. Okay, and you go over to the table, something like this, and you need to examine. You need to detect other variables. What makes difficult? There are also other given that is not used in the equation. Trying to confuse you only. Only this given, you can use only this simple, reaction for the constant equilibrium expression constant, like that formula. And then there are other, given that will try to confuse you. They give you the density, they give you some students also will try to include that. So it is not included. Okay, they will try to force to include that in the formula because it's given in the problem. They think that it is necessary because it's put in the problem. It's not like that all the time. There are times also that it's not relevant because it's not being part of the formula for the particular, confusing only the students. Okay, like this. And that's the time concepts, theories, principles will come. Okay? Because that is not applicable to this, blah blah blah, so and so like this. Especially when the gas is not moving, like this. You cannot apply the volumetric flow rate or the diameter, the pipeline, something like this. Okay. I don't think so that in dissociation gases, you will ask, what is the diameter of the pipeline when the nitrogen gas will. You also have the combination of the dissociation. It is very difficult, right? Trying to get the diameter and then involving also the equilibrium constant in that equilibrium. It's very difficult. I think in most cases, it's only in the PV and RT. I think so. Okay? But sometimes it's really, you cannot understand sometimes. It will just be unexpectedly goes to be like that. That's why you need to analyze. Okay, but then I have poor analysis sometimes. Especially when I am confused with other variables. Okay, it could not be denied. Okay, I will be confused really. I think sometimes it will be required, but in problems that question A, question B, question C. I think so like that also, right? For example, letter C, you are required calculate the area of the pipeline like this. You can compute because there's a PV and RT, right? Pressure is equal to force over area. So you can insert that there. And then just leave the equilibrium gases dissociation. Maybe it's asking letter A, what is the molar concentration of the reactants in blah blah blah, letter A, letter B. Letter B, what is the direction of our reaction if we add more concentration in the reactant? The direction of the reaction will go to the right, like this, letter B. Letter C, what is the density, like this, like blah blah blah, density approximate over volume, or calculate that through other formulas by using the molar density in the real gases and in the ideal gases. Okay, so use the van der Waals equation for real gases also, like this, or the ideal gas law, general gas equation in the gas topics. It will always be included somewhere along the way, like this. Integration will be there, integral calculus, and differentiation before you can compute to the concentrations of the reactants in the nuclear reactor, like this. Because usually chemical reaction engineering or CHE kinetics are always referring to the rate, the rate of the reaction, and then mostly it will be expressed in differentiation, integration, like this, really. D over dt, something like this. Problem. That's why you cannot take that without passing the differentiation. The formula of those will be used there to compute the rate of the chemical reaction in the certain reactor. Okay, like this. My gosh. This will be they will bring this to the laboratory. Okay, that's what I read. It will be extracted in the laboratory by the use of acetone. Acetone of chlorophyll will be analyzed through the spectrophotometer machine will determine the content of this cucumber, which is of carbon, how many atoms of hydrogen, how many determine the formula of chlorophyll. Okay, by using the formula of chlorophyll. Okay, by using the spectrum in the laboratory through the solvent acetone extraction in the laboratory. Okay, so you can determine now. So what I remember is only the atoms of chlorophyll have 55 atoms of carbon after that in the laboratory. Charot. I don't remember the hydrogen, the oxygen. So only the 55 because it's easy to remember. There are 55 atoms of carbon in that green pigment of green leafy vegetables, any kind, meaning cucumber, cabbage, lettuce, ampalaya. So all of them have a green pigment of chlorophyll. Now, in order for that we can have the photosynthesis. Okay, this carbon dioxide and water, okay, will produce the oxygen gas we breathe out of plants because the food coming from plants, like the carbon 6H12O6, that will trigger that our blood pancreas. The pancreas will control the level of the glucose level in our bloodstream. Okay, pancreas, synthesis reaction, and then chlorophyll like this. So directly speaking, we cannot survive. We will not die. We will die without chlorophyll. Okay. And are you sure all people know this? That without chlorophyll, we will die. I think most of the science students only, or the engineering, BS Chem, or sciences courses know that, but the other courses will never know that. They will die without chlorophyll. Okay, because chlorophyll is coming from the plants that will convert oxygen and glucose in. We are intaking that every day for our survival on Earth. Water is not enough to survive us. Okay, we need energy. Okay, like this to support our organs inside. So in short, photosynthesis action, okay, the conversion of chemical energy through the radiant heat of the sun to produce oxygen gas, like this. Oxygen and glucose, like this. So chemical to light energy, right? And to the energy that the human body needs. Okay, so 3 steps from chemical energy, which is the reaction from the chlorophyll to the carbon dioxide water. Chemical energy, the light energy, which is the heat of the sun. That's why it's called photosynthesis, because the word photo is the photo coming from the sun. Synthesis meaning combination reaction. That's what I discussed in my types of chemical reaction. That's why photosynthesis, meaning the light is being added, okay, to the chemical. So chemical energy, light energy, then our body energy needs. So convert to any kind of energy. It could be a kinetic energy, potential energy. Yes, because there's no electrical energy. Yes, it could be, because we have also current, a small current in our body. Yes, so that's what I remembered, okay? We have also current in our body, but only a small percentage of electrical energy, okay? But more of it is body energy used for, in our work, to perform our tasks. So that is kinetic energy, right? When we do something to move, okay, and we cover a certain elevation or distance, it's kinetic energy, right? And then potential energy, if you are steady in the particular place, but there's still energy and kinetic action originated in the energy. Okay, so automatically, when we speak about chemical energy, it's just like a vehicle to that. Okay, and it will ignite, move. So that's it. From chemical energy, Okay, because the cars and vehicles are already moving. Kinetic energy, right? In motion man siya. 3 laws of Isaac Newton, okay? Others on earth, about you will survive. Like this. Because even though I don't know how to compute, but I can eat food. I can survive. Then I calculate how many food I eat, right? But there's no mathematics there. Okay? So, if this say mathematics and science, okay, that's only complementary with science, mathematics. But for the reason of surviving the earth, science is the most, especially venomous like this. Without the earth, we will not live also. And science really is as a subject, except medicine is also under science. Okay? That's only the product of science, the medicines. Through the continuous experimentation, trial and error in the laboratory, That's why they can come up with the medicines. Technology like this, through science again, the basic foundation. Okay? All medicines started with science, not mathematics. Okay? Like this. So every day is a discovery. Every day is a science. Authorities that their discovery will be valid, and then it will be again retest. Okay, to show that these statements law are valid. So you can back up that with formula, right, or equations, something like this. Formula will come in. It's theory first and principle. To validate, follow this one like this, but it's all started with a scientific view. Okay, the scientific method, I'm discussing the scientific method first, gathering the data, information, observe, be an observant like this, and you should have your own inference. The trial, and after that, you have the conclusion if it is really valid or not. Okay, so that is scientific method, scientific flowing and starting with the number one, gathering of data information like this. Number two, to be observant and keen observant in the environment. Okay, whether it could be in the land, in the air, in the water surfaces. Okay, number three, develop the inferences. Inference meaning that could be like this. So there's an analysis. The difference between inference and observation is just the same. But the observe is just only observing without analyzing the effect of it. You difference. The inference is after you observe what's going on, you analyze and evaluate the impact and the consequence of what you are trying to observe. If it's really, successful, subject for rejection, so that is an educated guess or the hypothesis. And the last will be the conclusion. If you really prove that your hypothesis is really valid, logical enough to all the people like this or particular population, and then you can create a new conclusion like this and have the scientific research full. And then after that, so to prove it from step 1 to step 6, you have formulate your own scientific law. Okay, your scientific law will quantity measurements already, not statements, It is quantifiable and measurable. So, it's not more based on the numbers, okay? That's why we are now having the problem solve scientific law. Okay, algebra, integration, that is only as a result of the scientific law, meaning to say the scientific research has been done already, okay? And then you have the scientific law. Through the evolution process from century to century, and new generations coming. So we have to upgrade the technology. So the technology will be backed up with that scientific law and that scientific research, and then with the application of the technology to make it faster. Okay, to make it faster to understand things around us. That's the purpose of technology. That we have that scientific statement through the individual actions, okay, to the technology, how it can arrive to outputs, okay. For example, if I will make this data, I can make this data, I can present this, I can print it out. So that's an output already, okay. So that is through technology. It's a scientific research. Where is the mathematics there? And where is the science there? It's incorporated in the scientific research. Okay, like that. The technology is for the modernization of the tools, mobile phones. This is a result of the technology. Okay, but this will not become a technology without that scientific now. If there is no scientific research at first, of course we have to research first before we come up to the product. In a department, that's their job to research and to formulate new products. Because the time is changing. So if it's other products or new products, of course, they go back to the basic, which is the scientific method, and after that, scientific research, and then scientific law, and then the technology will come, okay, to produce the products also. Okay, so another technology will be introduced for it now, again, through evolution. Evolution meaning discovery, regular discovery through time. New technology will be coming like this. The only way to do that is to develop and strengthen our, or we need to have a strong scientific research, okay, and scientific law for that. Scientific research is enough, okay, very good. Too much explain, my gosh. Okay, this thing I really learned. This is already mentioned in the high school education, but I did not focus too much attention for this. It's not also discussed very well also in high school. In the college, it's always numbers. Believe me or not, it's always numbers rather than the theories and the concepts. Though not all, but most of the engineering students, engineering graduates are focusing more on the mathematics when they graduate. How to compute, how to blah, blah, blah. But for me, that is a wrong concept. It should not be like that. It should be up with mathematics because you cannot do a formulate or operation. Mathematics immediately. No, it's not. You should start with thinking it's gonna be environment. This could be produce quality to the environment, to the people behind who perform this product like this. It will start, the analysis will start like that. It will not go directly to mathematics. Oh my gosh. Later it will come there in the purchase department, in the accounting department. Later, there are already the results part. The accounting department, the purchase department, like this, the acquisition department. Later, after the research has been done, that's the process. That's the life cycle of a plant. Okay, it should always start with the scientific research. Okay, so I learned that a lot in my masteral study in University of San Carlos, Cebu, because I took up my masteral there. Okay, but I did not finish. Okay, I'm only taking up how many units there. Okay, so it's being discussed well there because you will report in front of the instructor or your professor. They will give you a topic and you'll be able to discuss this to the class. You're acting like a professor to them. And then the professor will just sit like this. It's not like in the college, in high school, the instructor will just although they will not standing a long time in the blackboard to teach you. They will take a seat and they let the students to do the discussion, like disability study, okay, in the, if you're taking your masteral, okay. Before I'm taking the MSES Masters in Environmental Science, I stopped. Only for half a year. I didn't finish it in 1 year. Okay. Okay, like that. So I took that Masters in Environmental Science. It's related to my course, which is chemical occupational. I took that MSES, Master of Science in Environmental Science. So it's really, it's really linked with my profession and my career. That's why I choose that one. Okay, like that. Okay, that was long time ago. My gosh. I stopped it because of prioritization. Okay, prioritization. There is family like this, and then you're acting as a breadwinner sometimes, not sometimes, all the time like this. And then you cannot budget your, own growth sometimes. Then it will be set aside for a while like that. And then since you're enjoying work now anymore, you can no longer go back to that study. That's the main reason. It's not that due to the reasons behind. Okay. Hello guys, shout out po for watching. Oh, you are still here. Thank you. I stopped solving problems because it's very lengthy, okay? And I have to write in a pencil pen, okay? And I cannot manage that, very tasky, right? So I eat vegetables, okay? Vegetables rich in antioxidants, it will help maintain our immune system, okay? Coupled with the AC because it's very cold. I don't know, I feel cold. And then your core body temperature is lesser than the temperature of the, like this, and you will feel cold even though it's still not yet cold, something like that. What about temperature? Or shall I say thermodynamics? Okay. Because it involves heat, right? Negative heat and positive heat. Negative heat is, cold or endothermic reaction. Positive heat or positive temperature is, exothermic reaction, meaning too much hot, like this, higher temperature, like this. Endothermic and exothermic reaction. Always that put into your meaning it's not an application of heat. So we need to say on the other side. Okay, that's it. Class. Remember that one, the other one will be the opposite. Okay. And the exothermic more on the application like that. So we need to say the more you are added with heat, you react very well. Only sharing of little knowledge. For example, me, I'm sitting here, and then if the heat will be going to my skin, I will like this. Yeah, that's true. I will react more very vigorous, right? Too much giving the concentrations like this. If you add heat, you will be more adding heat. It will. Oh, okay. So if you are involved in exothermic reaction, the impact will be extreme, something like this, compared to the endothermic reaction. That's why the reaction will be more vigorous. The rate of the reaction. Else, if it is not really that vigorous reaction, then you have to add a catalyst, right, to speed up the rate of reaction, right? And then the other one is the inhibitor. Can we put a catalyst? And we put an inhibitor to slow the and what particular parameters in a chemical reaction that we need to add a catalyst, something like this, because that chemicals are okay. So yes, because if you put that, it will speed up the reaction, right? So the direction of your reaction will go to the right, will go to the left. So it matters also catalyst, right? But there are also factors for that, something like this. Yeah. Oh yeah, perfect. Oh my God. My ace is very cold. How can I do this? That means I am hotter. Oh my gosh. Oh. Really, I feel cold. For spending your effort in watching my live streaming. Thank you so much. If you think you like video, just share it. If you try to think this is really useful for you or to anybody else, and then you can comment also if you want, okay, or like, or most of all, click the notification bell in the screen if there is also for the newest update of I am a singer, eternal voice, okay. Occupational safety, health, personal vlogs, science and mathematics, and music, singing, entertainment. Those are the coverage of my YT channel. But for now, I stopped uploading singing videos in my YT channel for the reason of copyright claims and copyright issues. So I established my other channel there. Okay, the other channel is entitled Exclusive Singing. Okay, and then / Authentic Vocalist.
Wow. Okay, this is really unique, right? My title unique. I don't see this title all over the world. If you see that in YouTube, there's no title like this. I created the title, okay, only my own, subjective opinion. Okay, others may not agree, but this is my YT channel. I can do anything, right? So positively, okay. Though sometimes it is exaggerated, but it's my own choice and my right and my privilege to put that title in me. Okay, exclusive singing slash or dash authentic vocalist, meaning original or primitive, not a copycat, something like that. Okay, so I will just let that channel to grow. Say going to the, you know, going to the, what do you call this one? The the peak of success, something like this. Okay, it's almost reached the requirement now. So little it will reach really. Okay, I think almost monetization process. Okay, so they are very strict. That's why all my copyright claims they use, and I mute that one. Okay, examination is their requirements, something like that. I just mute it out, and then I just put in the private folder, delay in the uh, monetization success. Okay, like that. Okay. And I'm very thankful to everybody, guys. And every time I share with you, you watch it. Though it's not really that a big number of views, but for me, it doesn't matter as long as there are still a lot. What? Not a lot. There are still some who watch my video colleagues before. Okay, and they know me personally, and I know them also. Maybe they are my neighbors in high school, in elementary, my colleagues before. Because I have friends Taiwanese also. Okay, before last 3 years ago. No, that's 2004 to 2007, and work in Taiwan. Okay, Republic of China. I have friends who are Taiwanese. Okay, I'm sing. I will sing because I remember in our particular company, I'll sing. Okay, in the anniversary, in the big stage for that particular presentation, something like that. And I sang warrior people at my back, which are also Filipinos doing the steps, interpretative tongues, and I am the one who sing the song. So it's just like a variety. Go other side, go other side. So I did it, and I performed it during our anniversary of the company. Okay, like that. Okay, so during anniversaries, and we have also the sports fest, the recreational fest every year, something like that. I miss that work in Taiwan. And also, maybe they are the colleagues in my Qatar days. Okay, last 2015 to 2018. Okay, maybe our contractors, something like this. Okay, because I work also in Aramco of contractors there also. Okay, maybe that that knows me also. Okay, and then also maybe that is in Dubai, in Abu Dhabi, colleagues before. Any nationalities, my friend, nationalities, whether it could be Bangladesh, Nepali, whatever, Pakistan, are watching also, okay, in my FB live, okay, my friend, because we are the contractor and we have a lot of subcontractors. Takrir oil company in Abu Dhabi, big refinery, something like this. We manage our subcontractors like this, okay, like that. Okay, as my colleagues before, as a QZ analyst and a product analyst also in the soft drinks industry before, okay, and also in the industries there as a technical analyst for water chemical analysis also for water treatment, chemicals, blah blah blah. So, and maybe also my friends in IPI, International Pharmaceutical Incorporated, okay, producing alcohol. And maybe also my friends when I work there in the Cebu Pacific Cheaters, okay. I was a color technician also. We have our clients And then we have a lot of colors of the furnitures. Okay, for example, chairs, like this, tables, and then we analyze the color effect or impact with our clients, and then they will choose what is the best design. Okay, I work that also in that kind of job. Just like a rattan factory, okay, furniture, okay, like that. But the color will be analyzed in the final finishing of the product. Okay, because there's a lot of colors, you will combine it, right? It's enjoyable also, really, the color, a lot of colors, right? Primary color, secondary color, really, and then it measures your, eyes, sharpness of your eyes, and you should be, first requirement, you should not be a color blind, because you will analyze the colors, what best color of this, and it will be, exported to another country. Okay, that's good there. So I work there. I have friends also there. Maybe they're watching also my act. Okay, okay. Because I have viewers, really. There's still somebody supporting me. My family, my friends. Okay, like this. And thank you so much. Yes, I'm almost there. I almost reached the climax of my, application for YT. And I'm very, very making. It's a sort of, I can share my talent to everybody, something like that, because God gave this. It could be related to occupational safety and health, or could it be my singing talent also, like this. That's all, like that. And then secondary is the money making, because after you uploaded that, you have the revenues. But that's only the secondary, but not really that first objective. The first objective really is to share my talent, and in order for me also to not to be boring for where I am now, something like that. Because imagine you're alone in the room every day, something like that. So you are far from your family, and then you don't have anything to do. Because I'm also bored in watching movies, okay? Because movies sometimes are fictitious. Fictitious? Fictitious meaning false. It doesn't happen in the reality. Something like that. And instead, you learn a lesson. It will confuse you sometimes also, because that's too much mystery. Okay, because you as a viewer, you will not kill somebody. You will just learn not to kill somebody. Okay, like that, the lessons out of it. But those movies in the YouTube or whatever. That's why I make this an alternative. For me, I'm very grateful, because the more I do this, the more I refreshed my information, because we don't know, I can be able to use this information or learnings in the future. We don't know, okay, someday, ever, because really my dream before, when I was in high school, I wanted to make my own book. Really, I author my own book in certain subject, but it doesn't come to reality. Okay, number two, I want to become a broadcast journalist, something like this, and it doesn't come true. Okay. So failure one, failure two, and then number three, I wanted to become, again, a doctor in chemical engineering, like this, and then I turned failure three, right? Number four, and then I shifted to another career which is related also to my course, OSH. In this field, I enjoy it the most. Okay, why? Because I meet so many people, and I'm not just focusing in the one box. Okay, one room. I exposed to different situations, what's going on in outside environment. I can really watch happening. Oh, the world is really beautiful. Something like this. I can talk to myself. I can make an email to share to anybody, sharing my ideas to different departments, something like that. It's really useful for me. It's very enjoyable for me for this kind of career. That's why I stick with this culinary. Okay, a lot will be covered. All engineering will be covered in OSH engineering. Okay, like this. Though my expertise is more on the chemical handling safety, because I'm a chemical engineer, right? From the initial stage to the final stage, more on the unit operations only, physical operations. It's not more on the chemical change. Okay, so it's not that really complicated. The company. So it's the product is solid. Okay, because if we deal with solid products, that is not more complicated compared to dealing with liquid hazard. Okay, but not that very high compared to those. Okay, because gas is the benzene tank will explode, what will happen? Something like this. For a company that producing benzene, company that producing toluene, company that producing alcohols, acetones, compressed gas, like this, methane gas, propane gas, butane gas. That is more very risky operations. Okay, that is more risky compared to the company that only put products, because the main reason solid products can be easily managed. Okay, can easily managed by, okay, but you can hold the soil by your hand. Imagine the difference already. If you have this product, for example, cement, you can hold the cement, okay, and put that on the pail. Can you hold the gas in your hand and you put that on your, on the container? So in that solid products, though both have hazards in the respiratory system, okay, because this cement has a silicate components that are carcinogenic, right? That is a suspected particulates for cancers, right? If the dosage is very high, it goes very, and above 8 hours exposure, something like that. So it's suspected carcinogen, like that, the silicates, something like this. SiO2, okay, carcinogenic substance. So that's the main hazards for a cement industry compared to the gas. So many, okay, in the respiratory system, and even you will die immediately if there's gas leak. For example, H2S, carbon monoxide. Oh my gosh! So that is deadly. Okay, so the level of safety inspection and monitoring is very strict and meticulous compared to the other one. But still, the principle of safety will be there. I'm just talking for the leveling, okay, of the degree of the hazards and risks associated with different operations. So could it be a physical operation or chemical operation, blah, 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 so on and so. Okay, like that, too much speaking. Di ba nagpaalam na ako? Bakit too much speaking? Okay. Hello guys! Thank you so much for hi and shout out to all the, Peachy, Peachy members also, Philippine Institute of Chemical Engineers, Cebu chapter. Hi, hello. I'm already updating my records there, and I do that in the morning, and then sometimes I'm working. How can I do the live, uh, tutorial of that modules? And the topic is very good. Really, I love the topic. Too technical, and I want to learn more technical in chemical engineering. But sorry, the time is not the same. That's a problem. Sometimes I'm sleeping, and you do already the live streaming of the modules like this. Very beautiful topic, right? Okay, I miss that. Oh my gosh. Shout out na lang for all the members of PCHI, Philippine Institute of Chemical Engineers Cebu chapter, and all chapters in the Philippines. And also the chemical engineering people. Okay, like that. Okay, and on to my friends, my family who always been there all the time. Through thick and thin, sorry, for ups and downs. Thank you so much. And most of all, thank you, Lord God, for everything. Okay. God bless everybody. Bye-bye. Mwah. Okay, and see you later. Thank you. Babush.